In part 2, I want us to cover 3 new properties called the product property, the quotient property, and the power property of logarithms. Logarithms as functions, because their output are exponents, can produce some interesting properties in addition to the ones we've already listed. The first one, the product property, says that for any positive real numbers x, y, and b, where b is not equal to 1, then we can say that log base b of a product x times y, so when you have two things multiplied together inside, is the same thing as log base b of x plus log base b of y. That the log of a product becomes the sum of two logs, log base b of x, log base b of y. And the reason is because when you multiply two expressions together with exponents, like this one, you add the exponents. So the product of an xy is the sum of the exponents of xy. Because logarithms are exponents, and we know that b to the m times b to the n is b to the m plus n. So we can verify this with a simple example, but I want to make sure that we understand how to use the property to do this. So take log base 3 of 9 times 3. This product inside here, I'm going to change and split this log into two logs added together, with the first one being log of 9 and the second one being log of 3. Looks like this. Log base 3 of 9 plus log base 3 of 3. That the value of this logarithm is the sum of these two logs. So if I check that, let's just go ahead and actually figure this out. What is the log base 3 of 9? 3 to what power gives me 9? The answer is 2. And 3 to what power gives me 3 here? That's 1. So 3 plus 1 gives me 3, which is in fact exactly right if you come back and think of this as log base 3 of 27. 3 to what power gives me 27. Notice it is the product inside here that becomes a sum between two logs. Now in this simple case, we could just calculate these numbers directly. This log became 2, this log became 1, then we added them up. Sometimes there's variables involved, sometimes there's numbers that don't have nice round logarithm outputs, so we simply split it up and leave it as the final answer. So like on this one, the second one here, we're going to take log base 7 of a product. Notice 49x is 49 times x. So we write that as log base 7 of 49 plus log base 7 of x. The product inside became a sum. So then the log base 7 of 49 here is 7 to what power gives me 49. The answer to that question is 2. So I can rewrite that as 2 plus log base 7 of x. There's nothing else I can do to simplify that, so that is the final expression. So the log of a sum becomes the log of a product becomes the sum of two logs. The quotient property says that if instead of having a product, having multiplication inside, you have division inside the logarithm, that it becomes a subtraction. So log base b of x over y is log base b of x minus log base b of y. So you subtract. You take the log of the numerator minus the log of the denominator. So like on this next example right here, if I wanted to simplify that by expanding it, I'm going to take log base 8 of 23 minus log base 8 of x. Log of the numerator minus log of the denominator. And again, the reason for that comes back to this reason right here, that whenever you divide two exponential expressions, you subtract their exponents. Well, if you divide this, you're going to end up subtracting their exponents. And remember, the output of a logarithm is the exponent. So that's it. There's nothing else I can do there because I can't actually evaluate this other than to plug it in my calculator. There's not a nice whole number, nice round integer that 8 can be raised to get to 23. So I want to leave it in that form. The second one doesn't have a traditional log in it. It's got the natural log. Remember, natural log is log base e. So we still treat it just like a log. So since I've got a quotient inside here, I'm going to take the log of the numerator, which is natural log of e to the fifth, minus the log of the denominator, which is natural log of 11. Remember, don't read it as ln. ln is not a function. We call it natural log. Because the natural log is the same thing as log base e, notice that on the first term here, the log and the e will cancel, and I'm left with just 5. But that natural log of 11, there's nothing else I can do there other than plug it in my calculator, but it's not a word problem, and it doesn't tell me to plug it in my calculator. I'm going to leave it in that form. Okay, so that's the quotient property, and the last one, the last property I want to mention is the power property. So there's one last thing we can do. We can take a log of two things multiplied together and turn it into the sum or addition of two logs. We can do the log of a quotient is the difference or the subtraction of two logs. And now what we can do here is we can take and write log base b of x to the r is the same thing as r times log base b of x. You can always take, let me back up, sorry. You can always take this r, if it's an exponent, if everything inside the log is raised to the r, you can bring that thing out front and you get the same value with the r out front as you do with the r in the exponent. Like on a here, you take that 9 and move it out front. Log of 8 to the 9th gives you the same thing as 9 times the log of 8. And you can verify that with a calculator. Try taking log of 8 to the 9th, which I have my calculator here. I'm not going to show you on the screen, but I'm going to type it in and tell you what the answer is. 8 raised to the 9th gives me, it gives me the number 8.127. And if I take 9 times log of 8, I get 8, I'm right, 8.127. So I get the same answer on either side. But this is the answer to that question. Okay? On the second one, I've got a little bit of a curveball thrown to you. You've got to remember that if it's the cube root of x, you can rewrite any radical as an exponential. Cube root of x is the same thing as x to the 1/3. So I can rewrite this as natural log of x raised to the 1/3. Then that 1/3 can be brought out front. And so what you actually have is 1/3 natural log of x. That's your final answer. Okay? In the next short video, I'm going to show you how we can do the 3 rules that we just learned. The power rule, the quotient rule, and the product rule are sometimes combined into one problem, and we can expand a logarithm across a larger exponential expression like this one right here. So I'm going to close this video down and start the next one.